Okay, exam 1, physics 101, fall 2016. Which of these best approximates the area of a twin mattress? Just the top part of it. A twin mattress is about, 2 feet by 3 feet, or excuse me, 3 feet by 6 feet. So that's about 1 meter by 2 meters. So we're looking at about 2 square meters. It's definitely not 0.2 square meters, and it's definitely not 20 square meters. That'd be like a 2 meter by 10 meter bed. So it has to be 2 square meters. The mass of your desk is approximately, it's about 20 to 25 pounds, so it's about 10 kilograms. It's definitely not A, 1 kilogram, because that's just a couple pounds, and it's definitely not C, because that's more than, that's like a football player, 100 kilograms. Which of these equations is dimensionally correct? Okay, so let's do one first. Meters per second on the left. Then I have meters per second squared. Meters, doing the square root of all of this. That becomes the square root of meters squared per second squared, which is meters per second. So one checks out. But notice that's not an option, so some of these others must also be. 2 looks a whole heck of a lot like our kinematics equation if I had a half right there. And so that one also is, but is correct. So let's just write it out. I have meters equals meters per second squared times t squared, which is second squared, plus meters per second times t, which is seconds. Cancels, 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 cancels. Meters, 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 so that one's okay. And then well, you could probably look here and say, I don't see 1 and 2, so it's probably going to be E. But let's just go ahead and show that this one is correct. I have X is in meters, V is in meters per second, times T, which is also in seconds. And then I have minus, I'm just going to leave out the 3, meters, meters squared per second squared, that's the V squared, times 1 over AX, that's going to be seconds squared over meters. That's that 1 over A right there. I flipped it and brought it up in the numerator. And then 1 over meters. So my second squared canceled there. This cancels with these two. And I'm left with these cancel. Meters, meters, meters. So it is E, in fact, for number 3. What must be the units of Q so this equation is dimensionally correct? Well, I can just solve for Q. And I get XV squared over A. And then I figure out the units for that. Meters, V is meters per second, but it's squared. And then 1 over A is second squared over meters. That cancels, and so I'm just left with B for number 4, meters squared. How many sig figs should this solution have? Okay, the way that it's written here, we imply, might go back and change this actually, that we have parentheses here so that I will do that operation first. So I'll add on your test some parentheses for number 5. When I do this, I'm going to keep 1 decimal place, so I will come out with, 15.7 divided by 4.92. Now it's important how many decimal places I have here, but it's also important how many digits I have here, because in the end I have 3 significant figures that I'm keeping, and I have 3 significant figures that I'm keeping here, so 3 will be the right answer. Consider the following right triangle. What is the angle theta? Well, theta, I have the opposite side and the adjacent side, so I say that the theta is the inverse tan of opposite over adjacent, 4.2 over 5, and that is equal to 40 degrees. So B is the right answer for number 6. This coordinate system shows a point at -3, 2. What is the distance from the origin to that point? So looking for the distance from here out to there. You can think of this as a right triangle, and I'm just looking for the hypotenuse. So I say the square root of -3 squared, or you can leave off the negative, doesn't really matter, plus 2 squared, and that's the square root of 9 plus 4, the square root of 13, which is what is that? Must be A, right? Number 7 is A. The volume flow rate tells how much the volume of a fluid passes a point in a given time. Typical adult has an output volume flow rate of 5 liters per minute. Your heart pumps 5 liters every minute. What is this flow rate in cubic feet per second, or cubic feet per second? Um, and you could tell that just from looking here, a cubic feet. Let's see, so I start with 5 liters per minute, and I want to get that into cubic feet per second. So let's first just get rid of the liters. So 1 liter is 0.001 cubic meters. That comes from right here, this unit conversion factor. And then I need to convert my meters to feet. 1 meter is 3.28 feet. Now, if you don't cube this, you're going to get the wrong answer, and the wrong answer is here if you don't cube it. And then I need to do the minutes to seconds. So I have 1 minute is 60 seconds. And if I do that, I get 0.005. 2.9 times 10 to the minus 3, 2.94, that's E. 2.9 times 10 to the minus 3 feet cubed per second, which is E is the right answer for number 8. And we're keeping it to 1 sig fig here because I only had 1 sig fig here. The standard for the meter is based on which of these? It's the distance that light travels. The speed limit on some interstate highways is 80 kilometers per hour. What is this in meters per second? Notice I have this little period here. That means I'm keeping 2 sig figs. So I have 80 kilometers per hour. I want to convert that to meters in 1 kilometer. There are 1,000 meters, so you need to know your metric prefixes. And then also my hours to seconds, 1 hour, 3,600 seconds. So all these cancel here, 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 and here, leave me with meters per second. So that's 80,000 divided by 3,600. I get 22 meters per second. So C is number 10. Throw a ball straight up with an initial speed of 50 meters per second. How long does it take for you to return to your hand? We might just say right off it is 10 seconds rather. Because my acceleration is minus 10 meters per second squared, I know that for every second it goes up, it loses 10 meters per second of velocity. So it goes from 50 to 40 to 30 to 10 to 20 to 10 to 0 until it goes up to the top. That requires 5 seconds, and then to come back down requires another 5 seconds. Ball goes up, comes back down again. It takes 5 seconds to come up here to the top. But let's just work this out a little more systematically. So up here at the top, I know that V is equal to 0. So I say that V is equal to V naught plus A times T. 0 is equal to 50 minus 10 times T. So T is equal to 5 seconds. But the answer is not 5 because it takes 5 seconds to go up and 5 seconds to go down. So A is not the right answer. E is the right answer for number 11. In a snapshot, a hockey player accelerates the puck from a velocity of 5 to 30 in the same direction. If the shot takes this amount of time, 2.02 seconds, calculate the distance over which the puck accelerates. This was one of the more difficult problems. It was very similar to one of your OpenStax questions. So let's write down what I know. I know that I'm going from an initial velocity of 5 to a final velocity equal to 30 in a time equal to 2 10 to the minus 2 seconds. I don't know what the acceleration is. It's not negative 10 because this is horizontal motion. And I want to know what is x. Well, I know to find x, I have to know V naught, I know that. I have to know T, I know that, plus 1/2 A T squared. I don't know A, so I need to figure out what A is. So let's look at this other equation, V equals V naught plus A times T. I can solve this for A. And I get V minus V naught, that's going to be 30 minus 5 divided by T, which is 0.02. That's 25 divided by 0.02. I get 1250 meters per second squared. So it goes from 5 to 30 meters per second by this acceleration. Now we can go and work this other problem, which is to find x. So x is equal to v naught, that's 5, times t, which is 0.02, plus 1/2 of 1250. That's my acceleration, which I've just determined, times 0.02 squared. And then that'll tell me what my distance is. Uh, 0.35 meters, 0.35. All right, so C is the right answer for number 12. Two bikes start from the same point. One bike has a velocity of -16 and the other moves with a velocity of 22 meters per second. What will be the distance between the two bikes after 45 seconds? Okay, this was a similar, or this also came from the OpenStax quiz. So one bike is traveling 16 meters per second. The distance is equal to v times t. Notice that this is really just a simplification of this equation with no acceleration. So I'm just looking at this first part. My x is equal to v times t. That's 16 meters per second times 45. 720 meters. And then the other guy is going in the other direction at 22 meters per second, also for 45 seconds. That's 990 meters. And to find the distance between the two bikes, well, one guy's going in this direction, the other guy's going in this direction, so you just add those two distances, and I get 1710, or 1700 meters. So 17 is the right, or C is the right answer for number 13. You drive 30 minutes at 30 miles an hour, and then for another 30 minutes at 50 miles an hour. What is your average speed for the whole trip? We had this problem actually in class or on the online participation quiz. It was verbatim. The answer is equal to 40 miles per hour. Because you're traveling equal amounts of times at these two different speeds, I can just take the numerical average of them, 30 plus 50 divided by 2, and that's equal to 40. Or if you need to think about it a little more, you can say, well, in 30 miles an hour for a half an hour, I travel 15 miles. 30 miles an hour at 50 miles an hour at 30 minutes, I travel 25 miles. So I travel a total of 15 plus 25 miles in 30 minutes plus 30 minutes. That's 1 hour. That's equal to 40 miles per hour. You drop a rock off a bridge. When the rock has fallen 4 meters, you drop a second rock. As the two rocks continue to fall, what happens to their velocities? Again, this came straight from the clicker question or the online participation question, and the answer is that both are going to increase at the same rate. Even though the one that you drop first is going at a greater velocity, but the two velocities are still going to increase at the same rate. All right, you move along this track measured in meters from point A to point B. What is your displacement? Well, your final is -1, -3, that's -4 meters, so C is the right answer. You throw a ball upward with an initial speed of 10 meters per second. Assume there's no air resistance. What is its speed when it returns to you? Equal to 10 meters per second. That was one of the basic ideas of free fall motion, that assuming no other forces acting on it, that it will return to you at the same speed at which it left you. Car is initially traveling at 10 meters per second in the negative direction. Then it slows to a speed of 5 meters per second, still traveling in the negative direction. Which of these positions represent the motion? So first of all, we're going in the negative direction. So that gets rid of this one, and it gets rid of this one. And I'm going with a big speed initially, so I'm looking one with a big slope. So that means my answer is B. Big slope, -10, -5 here, a little smaller slope. So B for number 18. Consider this position versus time graph. Which of the following best represents the velocity versus time graph described in this position versus time graph? Well, initially I have a big positive velocity, and then I have a small positive velocity. Big positive velocity, small positive velocity. So C is right for 19. Consider this graph. Describe the motion of the object for the first 3 time periods. Okay, well, what's it doing right here? It's doing nothing. It's just sitting in exactly the same position. So that could be this, traveling at a constant speed if the speed was 0. So we'll keep that one. Could be that one. It cannot be this one because it has a constant non-zero velocity. And it could be this one. All right, let's look at the next one. At B, what is it doing? Well, it's speeding up in the positive direction. So it's speeding up in the positive direction. Does it have a negative acceleration speeding up in the positive direction? No, it has a positive acceleration, so it can't be A. Let's get rid of that one. Does it have an increasing speed in the positive direction? Yes, it does. So it has A and B. We've already gotten rid of C. The object has a positive acceleration. So we're okay so far. So now we're either looking at B and D. Let's look at C. What is it doing in C? It has a constant non-zero speed here. The slope is not changing. It has a constant velocity. Constant positive speed. It looks like B is right, but let's look at D. It has an increasing speed. Not D. So the answer has to be B. It's not moving. It has an increasing speed in the positive direction, and it's traveling at a constant positive speed. So that was 20 is B. Consider this graph. What is the average acceleration between t equal 2 and 8 seconds? Well, first, just make sure we're looking at velocity versus time. Okay, we are. So if I'm looking for average acceleration between t equal 2 and t equal 8 seconds, I'm effectively looking for this slope. I can say 12 minus 6. That's the rise. 8 minus 2. That's the run. Or this is delta x over, delta v over delta t equals 12 over 6. 12 minus 6 over 8 minus 2, that's equal to 1. So it is positive, as it should be, because this line is positive, and it's 1 meters per second squared, so that's E. Consider the graph. What is the distance the runner travels between t equals 0 and 4 seconds? So I'm looking for the area under this graph from 0 to 4 seconds. So I'm going to do 1/2 of base. That's 4. That's my base. Times the height. Goes from 0 to 12. That's 12. That's 24 meters. So the distance that he travels is 24 meters. C is right for number 22. Consider this graph. What is the velocity at t equals 7 seconds? All right, well, this is 7 seconds, so I'm looking for the slope of this graph. First of all, it has to be negative, so I'm going to get rid of these because I know it can't be that. And then I'm going to do my rise over my run. So I'm going, it looks like from about 2 up to 17. So my rise is minus 15. I know it's negative because this is, negative, but if you're not certain about that, you just say 2 minus 17. That's equal to negative 15. All right, now I need to do my run. I'm going from 10 or 5 to 10, so that's 5. So that's equal to minus 3. So C is the correct answer, number 23. All right, vectors, 14 meters, 30 degrees below the negative x-axis. So that means my vector looks like this. What is the magnitude of the y component? So my y component is going to be there. I can draw my little triangle if you want. This is 30. This is 14. I'm looking for y. So that means I'm going to be the sine of 30 equals y over 14. Hopefully you don't have to go through these steps, but if you need to, that's okay. Hopefully you can just jump right to this and maybe not even write anything at all. So I got 14 times the sine of 30, which is 7 meters. C is right for number 24. Consider these two vectors. What is their sum? A plus B. And notice I've bolded this and I've written it out in words just to make sure that we understand that A is along the negative x-axis. Let's write this out. So my vector A is 4 units in this direction. And then my vector B is 12 units in this direction. So that's 12 at 30 degrees. So now I write my x and y components. AX equals negative 4. Being very careful there, because if you put positive 4, you're going to get the answer wrong. bx is going to be 12 times cosine of 30, and that is 10.4. I'm going to keep 10.4 there, and then by is 12 sine of 30, which is going to be 6. Now I add my x and y components to get Rx. It's going to be 10.4 minus 4. That's 6.4. Ry is 6. And I'm just looking for the magnitude of the sum. And so I use Pythagorean theorem. I say 6.4 squared plus 6 squared, actually 6.0 squared. That is 8.77 units. C is the right answer for number 25. Now consider these vectors. What is the difference? A minus B. So I first draw A. This is A. And then I draw the negative of B. That's negative B. Notice B was in this direction, but since it's negative now, I'm drawing it that way. And then my resultant will be this vector. So that is going to be A is 26. And finally, 27, vector has a negative x component and a negative y component. The magnitude of the y component is smaller than the x component. Which of these is the only appropriate angle? So it has both a negative x and y components. That puts it over here in the third quadrant. So I can get rid of this one, I can get rid of this one, I can get rid of this one. I know that it has to be somewhere between 180 and 270. Now I want to look at these magnitudes. The magnitude of the y component is smaller than the x component. That means that the vector is going to look like this, because this component is going to be smaller than this component. So my vector lies somewhere up above the midpoint. And so this goes to 180 to 270. That means that the midpoint is 225. So it's actually somewhere, is that right? Somewhere above 225. So that means the answer has to be E, 190. It can't be at 225 because that would mean that the x and y components are equal in magnitude. And the angle would be 0 degrees, or 45 degrees. So the answer here is E is 190. Here are the answers, but you can download these on the thing. And also notice that some of these came almost directly from OpenStax to actually more than just these three. There were several that were from that homework assignment.